Hi students, welcome back to that is your channel Physics by Imagination. Dear students, in the part 1 and part 2 we discussed about topics that is moving charges and magnetism. So it is very vast chapter. So I am going to explain in part 3 video 2. And in the part 2 video, the last topic was nothing but that is force carrying conductor of infinite length. We got the final expression, so that is F is equal to mu naught I1 I2 L divided by 2 pi d. So F by L. So here we are going to define ampere. So generally what is ampere? That is when 1 coulomb of charge is moved in 1 second is called 1 ampere. Now the force applied per unit length, that is mu naught into I1 I2 divided by 2 pi d. If distance is equal to 1 meter, if I1 and I2 is equal to 1 ampere, that is same is there, it becomes 1 means we'll get that F by L is equal to mu naught divided by 2 pi, okay, into divided by d is there. Mu naught by 2 pi is there. But yesterday I told you in the previous class, mu naught is equal to 4 pi into 10 to the power of minus 7. So if I substitute here, it becomes 4 pi into 10 to the power of minus 7 divided by, that is 2 pi. Pi cancelled. 2 1 jam, 2 2 jam. So this is 1 ampere is equal to 2 into 10 to the power of minus 7 Newton per meter. This is the definition of 1 ampere by using this derivation. F is equal to mu naught I1 I2 L divided by 2 pi d. So now here we are going to understand in this class, that is torque on a dipole. Torque on a dipole, magnetic dipole, and moving coil galvanometer. Okay, so now here torque means what, children? Force into perpendicular distance. So imagine this is a current loop, means we have taken a loop. Now imagine very important point, if it is the loop, imagine this is a loop. This is a loop, and here very important point, magnetic dipole. Dear children, in the current carrying circular loop, when it is moving in anti-clockwise direction and clockwise direction, very important point. So when it is moving in anti-clockwise direction, that is going to show north direction. In clockwise direction, that is going to show south direction. Anti-clockwise, if it is moving like this, that is going to show north pole. If it is moving in clockwise means that is going to show south pole. So that north pole, south pole we are going to see in the moving coil, that is current carrying due to circular loop. Hence we can find two poles, hence the name it is called magnetic current carrying loop act as a dipole. Okay, now so what is my point? That is very simple, that torque on a current loop, imagine this is the current loop and we have kept in the uniform magnetic field. This is uniform magnetic field. Then what is going to happen, children? Whenever current carrying conductor kept in the magnetic field, it is going to experience a force. So this will rotate like this. Okay, now here the force PQ and force SR will be, this is upward force, this is downward force. We know that magnetic force is equal to, that is Q, that is BIL sin theta. We discussed in the previous classes, that is the force acting on the current carrying conductor is equal to F is equal to BIL sin theta. BIL sin theta. Now what is my point here? Here upward force, downward force. The net force, that is FPQ and FSR, which is equal to 0. But this is a loop, PQRS is a loop, children. It is going to be rotated. Now the force on FPS and FQR, it is going to be rotated like this. Now FPS and F, that is FQR. So the force acting on this conductor is directly, we can turn as, which is equal to, that is BIL sin theta. This derivation we discussed in the previous class. Now if theta is equal to 90 degree, we'll get, that is F, the total force, that is equal to BIL. This is called equation 1. Now here we are going to get torque. What is torque, children? That is torque on this current loop. I am going to take a reference point, that is SR. It is going to be rotated in this direction. Then this is, I have taken at point O, and this is theta, and B means distance between this SR. So I have taken enlarged picture here. Now it is going to be rotated like this. Now we know that torque is equal to force into perpendicular distance. Now perpendicular distance is OR. So now force, we know that the torque is equal to F. Okay, F I am going to substitute, that becomes BIL into the perpendicular distance. Okay, that is perpendicular distance, nothing but what, children? OR. This is called equation 2. Now we want to find this OR. Now here, by using, this is, see, it is a right angle triangle. This is hypotenuse, opposite, adjacent. Now from this triangle ORS, so we can take from triangle ORS is equal to, that is sin theta is equal to, you know, opposite by hypotenuse, apo by hypotenuse. What is apo? Apo means OR divided by hypotenuse means, that is SR, and it becomes OR divided by B. I want to find this here. Now OR is equal to B sin theta. So if I replace this value here, so it becomes torque is equal to BIL into B sin theta. Dear children, length into breadth, that is nothing but area. So we get that expression, torque is equal to BIA sin theta. Again, the dipole moment is nothing but the product of current and area. So if since that is dipole moment M is equal to I into A, it becomes tau is equal to, torque is equal to B and M sin theta. So this is vector product of the two vectors, that is A cross B is equal to magnitude of A, magnitude of B into sin theta. So we can tell us, that is B cross M. Dear children, this is the torque that is on current loop, BM. So we got torque on the uniform electric field means what, children? That is P cross E. Please note down this. So after this, we'll go for moving coil galvanometer. Okay, so you can pause and you can see that. So now moving coil galvanometer, very simple. So what is the meaning of moving coil galvanometer? So very simple, our topic is to understand moving coil galvanometer. So dear children, it is very easy to understand that moving coil galvanometer. Imagine moving coil galvanometer. This is we are going to take a concave mirrors, concave horseshoe magnets, okay, concave, and we are going to keep a pivot which is connected with the spring, and this pivot is going to experience a mechanical force. So this is north pole, south pole, a curved shaped horseshoe magnet. This is pivot, and we are going to keep here a pointer to find the deflection. This is the construction part of moving coil galvanometer. So it is as if like motor rule. The children, motor rule means what? When our current carrying conductor kept in the magnetic field, then the conductor experiences mechanical force. Same thing here. When our current carrying conductor, this one coil, when our current carrying coil kept in the magnetic field, which is going to experience as a mechanical force. That is called moving coil galvanometer principle. Moving coil galvanometer principle. Okay, now this is going to experience as a torque. We got the expression torque is equal to mb sin theta, or we can written as torque is equal to m cross b. This is vector product of the two vectors. Now, so here moving coil galvanometer theory will understand now. Dear children, now here this is, imagine it is a pivot. Now here it is going to be deflected when we kept between the north pole and south pole. North pole and south pole. Now what is going to happen? Now this deflecting torque means this is the PQ, RS is the magnet, a pivot which kept between north pole and south pole, which is in concave horseshoe magnet, which is going to produce radial magnetic field to experience the mechanical force. Now what is my point here? This deflecting torque is directly given by BIAN sin theta. Okay, so this is directly we can take BIAN. This is called, you call this as equation number 1. Now this is deflecting torque. Now here the spring is going to experience as a force. That is called what, children? That is torque. Means the total torque is nothing but deflecting torque and restoring torque. Means when this coil is going to be rotated, that is called rotating torque, or you can call that restoring torque. So restoring torque is given by, that is K into theta. The children, this deflecting torque and restoring torque, when it becomes equal, then this is going to get rotational motion. Okay, so then if deflecting torque is equal to restoring torque, that is K theta is equal to BIAN. Very important relation we are going to write here. Now where K is called torque per unit twist. Theta means deflection in the pointer. I means current, A means area, N means number of turns in the coil. Now what is going to do, children? Theta by I. So that is BAN by K. So theta I kept, I sent denominator, K has come. So now this is called current sensitivity. Means what is current sensitivity? It means the deflection in the galvanometer per unit current is called current sensitivity. The amount of deflection which shown in the galvanometer per unit current, that is BAN by K. You can remember simple words, bank. So now we'll go for, this is the theory of this one, moving coil galvanometer. We got theta is equal to, it becomes what, children? Theta is equal to BIAN by K. This is the deflection which is given in the pointer. So you understood about current sensitivity. So this current sensitivity can be increased by increasing magnetic field, increasing area, increasing number of turns of the coil, but decreasing torque per unit twist. Now we are going to get expression that is very important, voltage sensitivity. See children, according to Ohm's law, V is equal to I into R. I is equal, that is V is equal to I into R. I is equal to V divided by R. Now here theta by I is there. Now here K theta is equal to, what is there here? K theta is equal to BIAN is there. I replaced by V by R. So B into V divided by R into A into N. Now I want current per unit voltage. I will send this side. Now it becomes BAN divided by R. This is called the amount of deflection shown in the galvanometer per unit voltage. This is called VS, voltage sensitivity. Very important for CET children. This is called voltage sensitivity. So after this, same thing, by increasing magnetic field, area, number of turns of the coil, we can increase that is voltage sensitivity, but we can't increase more and more because it has some disadvantages, because it's going to increase current randomly, so we can't increase apart from that extent. Now after this we'll understand that is conversion of galvanometer into voltmeter, and voltmeter that is conversion of galvanometer into voltmeter, and ammeter. Very important topics for CET children. There is a fixed question on this we can expect from this. So now first one is conversion of galvanometer into ammeter. So children, remember what is ammeter? It is used to find small amount of electric current, and it is always connected in series because it has low resistance. It has low resistance. Okay, now how can I connect galvanometer into ammeter? So if I connect galvanometer into ammeter, so low resistance means what, children? We should connect the resistors in parallel. Resistance in parallel. So if I take, that is galvanometer, and this is resistor. Okay, I'm going to pass the current. Current will move. Now here this is called current in the galvanometer. Now here according to, so Kirchhoff law, current is changing a different direction. It becomes I minus Ig. Now this is conversion of galvanometer into ammeter. So how can we convert? That is when the galvanometer and resistor are connected in parallel with low resistance. In parallel with low resistance. Now potential difference at G and R, or you can call S. Shunt resistance means a very small amount of resistance. So potential difference at G and potential difference at S. Now we know that Ohm's law, V is equal to I into R. So at G means it becomes Ig into G. So here this becomes I minus Ig into S. So this is called shunt resistance, a very small amount of resistance. It becomes S is equal to Ig into G divided by I minus Ig. Very, very important, children. We are going to use in the CET. Shunt resistance is equal to current in the galvanometer and resistance of galvanometer, what we current passed, and current in the galvanometer. Please note down. Similarly, conversion of galvanometer into voltmeter. So voltmeter has I resistance. Remember, children, it is always connected in series, and ammeter is always connected in parallel. So that is conversion of ammeter means what, children? We want low resistance, so we are connected in what, ma? Parallel. But here voltmeter, so sorry children, that is ammeter means connected in series because of less resistance. It will not affect the circuit. Voltmeter means parallel because voltmeter has more resistance. Okay, now what is my point here? When I convert galvanometer into ammeter, resistance decreases and current flows more. Now if I connect a galvanometer to resistor in series, this is series, then what happens here, children? Resistance increases, current decreases. Very, very important point. Here resistance decreases, current increases, resistance increases, current decreases. That is, how can I convert, that is galvanometer into voltmeter? When I connect galvanometer of resistor in series with I resistance. With what, ma? I resistance. Very, very important point this is. With I resistance. Now what is going to happen here? Please consider. According to Ohm's law, we can write, that is V is equal to I into R. Here resistor is 2, galvanometer resistance as well as normal resistance of the resistor. So it becomes V is equal to, that is Ig into R plus G. This is galvanometer resistance plus resistance of the resistor. Now I want to get this galvanometer resistance. Okay, then what happens, children? That is V by Ig is equal to R plus G. So now I want to get this more amount of resistance. I resistance is equal to what happens? R is equal to V by Ig. This I send this side minus G. So what is this expression here? The resistance, I resistance, this is low resistance. Now voltage divided by current in the galvanometer minus that is resistance in the galvanometer. This is all about moving charges and magnetism. So here important points, children, please note down. So by concluding this point, I have finished this third chapter. Next chapter will go for that is magnetism and matter. I hope you understood, children. If you understand, please share it and subscribe who are preparing for CET exam. Thank you.